Hi everybody. Today we're going to study about DHCP protocol, and we're going to see what are the factor which going to be covered in DHCP. So we have two part. First part, today we will do entire lab and we will understand the basic concept of the DHCP. And the second part we're going to cover post routing, means once I am able to complete the OSPF and the static routing, we will do second part of DHCP, that's going to be advanced option. So in this DHCP protocol we're going to concentrate on basically the process of broadcast and unicast. We should understand the layer 2 broadcast. We will do lab and we will try to understand, so what do you mean by layer 2 unicast, what do you mean by layer 2 broadcast. Same way in packet formation, how DHCP form the unicast request for layer 3 as well as broadcast, at what process. So in DHCP we have process that called DORA, discovery, offer, request and acknowledge. You can see in this diagram. So we have client, DHCP client, we have DHCP server, and the discovery going to start from the client. Then server going to give an offer to the client, and on the basis of that offer, so the request going to generate by the client. So we will see the client and server, the communication going to happen the port number, on the particular port number. We will do the lab and we will understand on the packet basis how the port level communication going to be identified. Means how server going to identify this client is coming for the DHCP request, is looking for IP. So the port number going to be responsible, neither your unicast or broadcast IP or layer 2 MAC address, that's not going to be responsible. So they will understand on the port level. So client having a specific port number and server having a specific port number. So we have two port number, UDP port number 78 and UDP port number 67. Sorry, 67 and 68. So one of the port is for client, that's a 68 for the client, is a source port. When they going to send the discover packet, we will debug, we will understand today. And the server port, destination port going to be 67. On this port number they will identify they are requesting for the IP address. And this is the server client model which have DORA request. And what do you mean by APIPA? The next thing, APIPA says that automatic private IP addressing, means if your DHCP fail, then only the APIPA will automatic going to assign if DHCP fail. And this range going to be 169 to 54. We will do lab and we will see that. We have complete lab for this automatic private IP addressing already, but we will do quick lab before starting the DHCP lab. Okay, so this is the dynamic allocation, no need to do manual. It's going to avoid to maintain the IP address in the database from a specific pool. So it's going to bind with the MAC address of the client with the specific IP, and it's going to keep maintain to lease out till the time it's a lease out or the lease going to be renew. So lease out and renew, this is not a part of CCNA. However, we're going to see in advanced DHCP second part of lab. Today we will concentrate how the communication going to be trigger on the packet level, and what are the UDP packets, the port number 67 and 68, how it's going to work. Clear, guys? So any question till here? Should I move to the lab and we will spend the time, quality time over on lab discourse? Yes, any question?
No.
No. Okay, let's quickly see the lab and you can raise the question over there. So we have to remember the key point. What are the key point? We're going to understand today in this class. What is the layer 2 unicast? What do you mean by layer 2 broadcast? Layer 3 unicast, layer 3 broadcast, and APIPA. And the process of discovery packet, we're going to see discovery, offer, request, acknowledge. So how the discovery going to be happened? Discovery going to be broadcast, offer is unicast, then you will see it's a really unicast or it's also broadcast. And how the art going to be generated, because once you will get your MAC IP, then network, when they're going to understand the network, they receive the ARF, entire network going to aware about that. Okay, so let's quickly, we will move to packet tracer. We'll move to packet tracer. Let's open tracer. So advanced lab we will do on the GNS. Okay, but it's the part 1 we will do here, and the third part we have DHCP that we will do in GNS, and we will see the debug and the packet level of stuff. Let's do the quickly. So we have already one topology. I'm going to upload that topology. So guys, you guys able to see my is a clear? You guys able to see the screen easily?
Yes.
Okay, thank you. So I'm not going to use the entire topology here. So we're going to use this part of topology only. This one router, we have connected switch, we have LAN B laptop 1, LAN B PC1, one DHCP server, this part 1, and router. This part we have lab on this part 1. So I'm going to move little bit that. Clear? So we have one router. The interface 0/2/2 is connected, gig 0/1, the switch called LAN B. So this LAN B means we have IP here. Let me write down the IP, the LAN IP 192.168.2.x/24. So we're going to do lab on this, okay, on this subnet. Okay, so we have lab in the same LAN DHCP. We're going to see this lab within the LAN only, and part second we will see advanced if the DHCP outside the LAN, if it is not in same network, and we'll try to understand each and every parameter for DHCP. Now, so my gateway will be 192.168.2.1 is my gateway. This will be my gateway. You guys able to see the screen, right? This is the gateway, and let me write this IP down. This is the gateway, and we have DHCP. DHCP we will assign the IP address 192.168.2.11 will be the IP address of the DHCP. Okay, and we're going to assign the pool of DHCP that going to be free in any the pool of IP from which the DHCP going to assign or allocate to the client. or PC or laptop. So that pool going to be 192.168.2.100 till 254. That will be, or 200 or 199, only 100 divided. So I'm going to give till 200 only. This will be the range. Okay, clear guys? So this will be range for till 200. No, okay. So this is the thing, and we have LAN PC, LAN B PC1, LAN B laptop 1. It's a connected to switch, and they are, if you want to, I want to show you quickly. I want to show you quickly what are the configuration of interface. So just how the connectivity. So this is LAN B switch, which is connected to all the server and the client, PC client. So I want to show you the port number of the client laptop connected on the interface 0/1. This is the laptop connected VLAN 200, and PC is connected VLAN 200, and the same LAN we have DHCP. Yes, is the port number 04, the DHCP in the same VLAN 200 VLAN. Okay, so this DHCP connected in VLAN 200, this laptop connected on the same VLAN, and the PC also connected with the same VLAN. So DHCP and this laptop and desktop are in same VLAN with the VLAN 200. Clear? And the gateway also router connectivity on the same VLAN, means gateway having same VLAN. Okay, now so let's go to the laptop one. Let's see there is any IP configure or not. So I'm going to on desktop. I can see there is no IP address assigned to this. You can check it. This IP config, I can see there is no IP address assigned to this. So we will going to receive the IP through the DHCP. And okay, now second PC also LAN B PC, also we can see that there is no IP address assigned till now. Okay, we are good to go. Yes, all the interface are up. Now come to DHCP server. First thing what we have to do, we have to enable the services. Try to understand here. So before enabling the services, we have to see all the interface are up. It's connected to the LAN switch. First thing. Second, we have to check this DHCP. We have configured already IP 192.168.2.11. This is the IP what we have, and gateway 2.1. So this is the gateway 2.1, and the DHCP IP is 2.11/24. Okay, so we have, this is a basic networking is completed. Let me test it. So we have IP address, we have server gateway defined. Let's ping gateway and test it out. It's a working NIC card and everything. So I'm pinging to the gateway, it's a pingable. I want to ping to the switch also. Switch IP is 192.168.2.2. This is the LAN B switch. You can able to see, just I want to show you. So we have, you can see this switch. This is the switch, LAN B switch. You can see LAN B switch having the management interface 200 2.2. So gateway is 2.1, switch IP is 2.2, and the DHCP IP is 2.11. So I will ping the switch, and We will see it's a pingable or not. Yes, first packet drop, I can see it's also reachable. So our LAN setup with the gateway is up and working fine. Now, so I want to study about the DHCP, how discover packet going to be happened. Now what I'm going to do, I will generate the DHCP packet and we will see what going to be the result. So I'm going to discover the DHCP as soon as in this laptop right now in LAN B laptop 1. For this I'm going to trigger DHCP discovery. I'm clicking that and we are waiting. So we try to see what going to be happen. So this telling DHCP fail APIPA is being used. Okay, so let's check it out on packet level. What happened? Why this failed? So I'm going to start simulation and I started simulation, and now I will go to laptop 1 and trigger the DHCP. So let's observe what happening. The packet moving from this to switch. You can see there's a DHCP packet move to the from LAN switch. Now it's reached to router 1 also, switch 3 also, PC also. But they are, have they reached to the DHCP? Can you see? Yes, they reached to the DHCP. What happened on DHCP? You can see that source packet is 68. I already explained you 68 shows that the client. I am the client. Source is client. So who is the source? Source don't have IP address, but source have may unicast. L2 unicast, layer 2 MAC address. Can you see? They have MAC address. This is called L2 broadcast. Means they have source MAC and this is the destination is broadcast. So this is the layer 2 broadcast. But if you don't have source IP, this is not going to called or deserve for layer 3 broadcast, because the in data format the broadcast, those who are doing broadcast, they must have one IP. So this is layer 2 broadcast example. But how the DHCP identify? Because you are the source agent, not a 00 IP. Because most of people know if we have IP 00, we will be the client. No, my dear. If you have port number 68, then only you going to be server DHCP client. Clear?
Yes.
Yes, that always remember. And destination is 67. Of course, is the broadcast. But what going to be happen? I can say there is no out reply. Means at the DHCP box, he is not replying him. Means there is something. Means he is not enabled for destination 67 port. Okay, so I'm going to stop this. Stop this and I will come to here. So I identify by debug the DHCP itself box is not replying on the port number 67, even though client request the packet came to DHCP device. Okay, so we will go to DHCP and I can see the services is off. Can you see? He is not enabled the service. Yeah, he is not enabled the service for the 67 reply. So let's switch on this service. So while you are switching on this service, you have to announce your facility. What are the services you going to give? Let me explain this. So you going to able to see. Are you able to see my screen full of DHCP box?
Yes.
Yes, thank you. So I switched on first. So why is the switching on? Switching on going to enable to reply on the destination. Destination 67 port, he will listen and reply. Okay, so we have right gateway, we have DNS server. Okay, we will give the IP range, the start IP I will give. You can customize any IP. I just started from 100. Okay, we have decided. So my IP will start from 100. So I can see the laptop or desktop receive the IP 100, 101, and 102, 103, like that. Clear, guys? Are you agree?
Yes.
Yes. So he will receive the IP start from 100, not before that. So Astos, what you will do before IP dot 99? Yes, we will keep reserve for something else. Okay, just we want to do the test. I want to keep the testing for 100 PC only. Okay, so means if they start from 100, it will give the 100 device IP, it will go to till 200, not more than that. I'm not going to assign any TFTP. I'm not going to assign anything for today now, for the today's lab. And I will save it. It's a save. The name is server pool, and this is your default gateway is this. DNS is means when I'm going to check the client, they will receive default gateway this, DNS server information this, and they will get to one IP with the MAC banding with the range start from 100. Clear?
Okay.
Yes. So let's do the debug again. I'm going to simulation on, and this time again. Oh, no, I think. Okay, let's remove this, and again I'm going to start my request. So this request is starting, and we will see how. And we started the packet. So the DHCP request started from this first packet. Let's see what is the packet. Let's understand what packet came out. The device is LAN B laptop 1. The device is LAN B laptop 1, and the source, the packet started from our laptop. So what packet formations? This says that my MAC address this layer 2 multi broadcast, because my destination is FF. My source, of course, I don't have IP. That's why I given the source port 68, because I'm this DHCP client. By 68 port I assigned my packet, means I'm looking for IP, and the destination 67. Who can give the service on 67? Of course, it will reply by the only and only the DHCP server. Okay, so layer 7 says that the DHCP packet server and client, so they don't know who is the DHCP server and the client. So let's move to next packet. I'm going on the top, and I try to see that it's, I think request is completely happened. I'm going to stop this, and now I'm going to study, because otherwise I can't study. I just want to see the another packet, same packet, the same packet, and then it's went to the LAN B switch. The packet moved from the laptop to the switch. What switch? Switch does not understand the layer 3, layer 4, layer 5. So you can see he's aware about the MAC address and the destination MAC address, and he make the output this packet to all the interface. It's a broadcast with the source MAC. Okay, and you can see the port number. So he received the port on this, he broadcast the port number 34. Go to next. Let's move to the next. Is the LAN B PC. It's this packet reached to the another PC. From laptop it's reached to the another PC. Is asking you are the server. who can reply on 67. PC says that no bro, I'm not. So he did not reply anything, he just ignored. If the packet broadcast, it will reach to PC also, it will reach to router also. So they ignored, they did not reply because he is not listening on the packet 67. So responsible, who is responsible? Who has service enabled for the 67 packet. Clear guys? Now it's reached to, you can let me see who is the next. So DNS server also going to not reply anything because he's not responsible to response this. So you can see this broadcast packet reached to everyone, but no one responds this packet till now. Now it's reached to DHCP. It's reached to, you can see here at the DHCP. He listened the packet, but he did not reply at this time. Then what's the next packet? For this also not replied. I can see there the not replied yet. So come to this here. The first time it's not replied because the service was not enabled. But here DHCP, they have listened something, and there is a out packet for layer 2. So what has done next once he listen? So you can see DHCP box what replied has done by the DHCP. So they reply as a ICMP packet. Can you see? It's a reply with the packet ICMP. So first packet he listened that because he tried to respond layer 7. Try to respond layer 7 because he's responsible to listen on the port 67. And you can see next packet, it's a ICMP packet, means it's sending ICMP packet with the destination MAC 2.100 first IP from the pool he assigned, means this is called offer. This is called offer. Now so come to the router. I don't want to discuss about router. After that you can see DHCP-Offer. This is important. Means now it's doing ARP banding itself database on the DHCP because he assigned one and the offering for ICMP with the IP address 192.168.2.100, the MAC address with, okay, and it's going to broadcast to everyone because everyone going to get to know about this IP is assigned to the so and so MAC. So please register the ARP entry in your database on the LAN each and every device, so that if anyone having this IP, they're going to reject, they're going to inform. Clear guys?
Yes.
Yes. Now what happened next? Now come to the, we are LAN B switch also going to do the ARP entry. Can you see ARP entry here? ARP entry, this they will build their ARP entry. Means even though your PC not received the IP address yet, but your LAN going to know about this IP going to assign to you, means your MAC going to associate. Because why it's important to everyone to know before knowing the actual PC? Because if anyone having that IP by mistake, so they're going to respond to the DHCP. Clear? So this process is, it's mandatory to check the ARP entry. So you can see before DHCP request complete, they go for each and every device. Now it's came to the laptop 1, means now, and they are telling laptop 1 itself, you receive this IP and make the ARP entry first. Your IP going to be this, you map with the Now you
So,
can see next.
sir, I have a doubt here.
Yes.
So how will make sure that this broadcast go to other devices first than the one which requested for IP? Like in this case, how will we know that this laptop which is requested for IP, before that this goes to everyone, that this IP is being assigned to this laptop?
Okay, so let's come little bit earlier, that you can see the packet. I'm coming on this, the right side top, ICMP. If you see DHCP, this DHCP device, for DHCP first, second packet I'm going for ICMP. After that, what packet is released? It's doing the ARP entry. Okay, while it's doing ARP entry, it's done ARP entry DHCP itself, and you can see what packet sending out layer. It's sending the out layer packet. Can you able to see DHCP sending the out layer?
Yes. Yeah.
This is the DHCP device, and the destination is broadcast. A source is DHCP. So this is layer 2 broadcast. This is layer 2 broadcast. Can you see?
Yeah.
So this can be done in unicast also, because this communication going to be happened laptop and DHCP, but it's not doing. He can do the layer 2 unicast, layer 2 unicast communication between the PC, between the laptop and DHCP, but it's not doing. It's doing the layer 2 broadcasting, so that everyone can do the ARP entry. So while you are doing ARP entry, so you will check your ARP entry. If someone else there already with the same IP, some other MAC, you will reject. You will inform back to this guy, because he is the source.
Got it.
And
Yeah.
got it?
Yeah.
So you do lab and you see each and every packet, you open and understand. So it's going to help you to understand, and you can confidently, you can going to explain in the interview how, when, and where, and why. So you can see everyone in the series, they are making ARP entry, means they are checking their ARP table. Is it there is any entry with this IP or not? If not, this is one new entry, let's add that. Okay, so I'm not going to aware about HTTP. Come to again DHCP ICMP. So what is source? So this DHCP, they send on this, and now he is testing. Now it's a testing is acknowledge. It's a testing. Yes, you get assigned to destination. Now this is the unicast. You can see there is no layer 2 information. This is a unicast, pure layer 2 unicast pinging ICMP. Earlier it was the layer 2 broadcast. Are you clear?
Yes.
This is acknowledged. Now it's a confirmed, and it's make ARP entry, ARP packet source. Now it's confirming and making the ARP entry. It's a final ARP building. If you go down, that's the acknowledge. There is no DHCP packets complete. So means, so come to this. I will receive IP or not? Let's see. There is IP. No, not yet received. Let me stop this, because the packet lost. So I will come to real one, so that we will receive the IP. You can receive IP. Can you see that? Sorry, DHCP. Yes, we receive IP, guys. Okay, come to same. If I want to see for the IP same way, what is the process? Go to DHCP, just click DHCP, and we will going to get the next IP 2.100.2. So let me check and do the pinging stuff. So what is the IP address? So I got the IP 2.1.2, and this is my IP. and same way I will check here what is the IP address, and we will able to see we can receive the IP address by DHCP. Let's ping and test. It's everything is reachable 192.168.2. I will do my self pinging. It's working. Now I will do gateway. Gateway is reachable. I will check with the switch IP. That will take some time because first packet it must drop. Okay, now I will check my DHCP server. So it's working. Same way I will test for the gateway 192.168.2.1. So okay, so by this the DHCP part 1 is completed. Please practice on this and post your query, or I'm going to upload this topology. You can test, you can configure. So I'm going to summarize here what happened with this process. First, I took the router as example 4300 ISR router and 2960 switch model. You can see that, and the laptop, desktop and PC remaining you have already know about. So let's quickly summarize this class. So we have DORA process, discovery, offer, request, acknowledge. Discovery is the 68. They're going to start the communication with 68, and the response will be from 67 protocol. Okay, so 68 for the client, 67 for the server. Now they will going to broadcast this. This is the broadcast, layer 2 broadcast within the LAN, and the server going to listen or not on broadcast IP, it's listen on the 67 port number. And then offer, with offer they will ping and they will trigger with the ARP entry also. They're going to know the ARP entry. So once ARP entry, they're going to check their every switch, every LAN device. Then the request come to from the client, and again the panel they will give the ICMP packet as well as ARP packet. Final build up their ARP entry with the IP allocation. If DHCP fail, so we have automatic private IP addressing. That's range is start from 169.254.0. This is only for LAN communication. It's not good practice. We don't have any DHCP in the LAN. By this I'm going to stop class. We will see you in next class with the advanced routing and switching.